Thank you very much, and thank you all for coming. So, as you said, today we're going to talk about the lesson learned at ContentSquare about the frightening topic of data migration. So, I'm Thomas Franquelin. I'm staff data engineer at ContentSquare, and basically, ContentSquare is a company that collects, a lot of anonymous navigation data from websites and mobile apps in order to compute statistics that are going to be used to improve UI. Right, so we're going to talk about these migrations in the context of ContentSquare, so it's fairly important to understand it. We're going to talk about the tools that we built during these migrations to ease the process and how we use them. So at ContentSquare, we migrated twice in a row. We changed our data store twice in a very quick fashion. We went from Amazon Redshift to Elasticsearch, and then from Elasticsearch to Clickhouse. So at the beginning, originally ContentSquare was using Redshift as its main data store. And we used it with a very flexible data model that allowed us in the first days of the company to iterate very quickly. But the price that we paid for this flexibility was performance, of course. So the most difficult computation had to be scheduled, and our user experienced fairly high latency. So around 2016, we decided to change the old data architecture and to move towards an architecture that was centered around Elasticsearch. So this allowed us to perform live computation with usually subsequent queries. But the catch was that this data architecture is very expensive. So we're talking about hundreds of servers. And so in the footsteps of this first migration last year, we decided to move away from Elasticsearch and to build a new architecture centered around Clickhouse, which is a column-oriented database that is open sourced by Yandex. And we changed pretty much the whole architecture, so it's more scalable, and most of all, it's more cost-effective for us. And we did all this in a context where the traffic that we had to handle essentially increased tenfold. So we had to of course, avoid any regressions while we were changing the architecture, maintain the service available because we didn't really want our clients to experience a maintenance window, and we wanted to keep the inevitable data gaps, if you want, between the two solutions under control. So we have to remember that we are talking about an analytics system where we kind of rely on some approximations in order to compute data on vast amounts of data very quickly. And so one challenge is to make the distinction between the statistical errors that can creep in and the genuine regressions that can appear when you migrate. The other challenge is that there is really an infinite number of questions that you can ask our data. So this is a very partial and simple extract of the interface that our customers can use. And as you can see, they can play with a range of parameters, population segment, device, URL patterns, time range, and so on and so forth. And so there is really an infinite number of combinations that they can use to query our data. And so it's futile to believe that you can try each and every possible request and compare the results on the two systems, of course. So you need to devise a strategy to do that. So which tools did we have at our disposal to conduct this migration? So first of all, as with any project, we have our array of automated tests, so that's a given. I don't want to expand too much on that. What's more specific to data migration is usually having an array of custom database scripts that ensure a certain number of invariants while you are migrating. For example, that you have the same number of user sessions, at key points in the process from one system to the next. These kind of things. At the other end of the spectrum, you also have manual QAs. You want to ensure that a human assesses that the two systems, like the old system and the new system, behave in exactly the same way. And that's basically the array of tools that we had during the first migration from Elasticsearch to, from Redshift to Elasticsearch. And we noticed that it was somewhat insufficient. Because at the end of the day, you want to ensure that, that the request that you are making to your system yield the right results. And really, with your end-to-end test and with the manual QA process, there is only so many queries that you can issue to your system and ensure that they are right. And only the most simple case can really be assessed. So because of that, many bugs actually crept in during this first migration, and the validation and correction cycle took a while. So we decided that for the next migration, we needed more tools to allow us to play many more queries that was possible with the first iteration. And for the rest of the talk, I'm going to talk about those tools, which are mostly comparators. And we have two kinds of comparators, the focus comparators and the production request comparators, and we'll dig into those. So what are those comparators? So first, a quick step back. So the migrations I talked about were not just about changing only the data store. It was really about changing data model and changing all the components in between. So we're talking about changing a dozen of components. So it's a very heavy migration. And because it's a very heavy migration, you don't really want to switch all your customers overnight. So it's a phased migration, if you want. And during the weeks or the months that this migration occurs, you want your front-end components to be able to talk to the two backends, the legacy backends and the new backend at the same time. And to do this, we have an adapter layer that is able to translate front-end queries to both backends. The idea of comparators is basically to leverage this adapter layer to be able to replay the same request basically on both the legacy and the new system, and to save each individual result into a database for further ad hoc analysis. So you want to be able to save the results in the rawest form possible so that you can then analyze them and aggregate, really explore the data in any way you like, with the possibility to still go back to the original request to investigate errors. So to make this a bit more tangible, this is the kind of record that you can have in this comparison database, and you can see that we are saving the request, the URL that corresponds to the request that we issue to the respective backends, and we save also the body in this in its raw format, which is JSON in our case. And with just that, with any decent database, you can actually export data in any way you like. So in this case, for example, we wanted to look at just the relative error of the loading time field that you saw in the previous slide. And we chose to aggregate it in any way we like. In this case, we are looking at the quantiles, the higher quantiles of error, but really it could have been like the max error, or it could be the average error, whatever you want. So this is the generic idea of comparators. So it's fairly simple. You just issue the same request, you compare the results. There is nothing mysterious about that. The only difficult question that remains unanswered is which requests are you going to issue to your comparators? Because as we said, there is an infinity of such requests. So we have several strategies here, and that's why we have two kinds of comparators. So the first one is what we call focus comparators, and the idea is very simple. Basically, you want your system to be able to handle many different aspects of your queries. So you want your system to handle segment of population in a correct way, or metrics in a correct way, etc. And for each of these dimensions, we want to play a series of requests where each other parameter is fixed, basically. So say we want to ensure that all our metrics are correctly computed. Well, it's fairly easy. We just fix the device to be always the same. We just look at always the same time range, the same segment of population, the same page, and so on and so forth. and we issue one query per metric, and this so this is a very simplified view, right? And it allows us to see if one metric is totally off the chart in terms of relative error, for example. But we could have done that as well for segment of population, for example. In this case, we would just fix the metric to be, I don't know, click rate here, and issue one query per segment of population to ensure that each one is computed correctly. So this looks fairly natural, and if your system is orthogonal enough, then you might think that by correctly handling each dimension of your queries, at the end of the day, when you combine everything, everything works. But of course, you can never really be sure of that, and subtle side effects can creep in. So you want to also mix all these parameters together and come up with a totally different combination of queries to ensure that your system works as it should at the end of the day. And really, you have two ways of doing this, I guess. One is to come up with totally random array of random set of queries. But as Michael said in the previous talk, it's not that easy to come up with realistic random queries, if you want. So our approach instead was to leverage the real queries that were issued to our system. Basically, of course, we log every request that is made against our system. So this makes for a perfect database of query to be replayed on both systems. So the source of our queries to be tested becomes the queries that really happened in production. And that's fairly interesting because it gives us a realistic expectation of what will happen to our customer if we were to switch overnight. Because really there is no better prediction of the future request than the past request. So it's really useful for feature validation. We can give numbers that are fairly easy to understand for the stakeholders. So it acts as a perfect communication tool. But you cannot really use this instead of the focused comparator to actually find and narrow down on your errors, because really when you find a gap that is unacceptable between on the production request, it's really hard to understand where it comes from, since all the parameters and all the dimensions are mangled together. So it's useful to first use only your focused comparators to find out where the errors are and to isolate them, and then only this production request comparator in a final validation phase. Right, so correction cycle. How do we use these tools? And by the way, I apologize for the stock photo. It's not great. So basically, let's. Remember, we first use our focus comparator to kind of narrow down on our error. So let's go back to our example of finding out if any matrix is incorrectly computed. So what we first want to do is have a bird's eye view of all of our gaps for all our metrics. And here we quickly see that the activity rate in particular is totally off the chart, while the other metrics looks fine. So the next step is to try to narrow down on the particular set of requests that concern the activity rate. And we can do a breakdown, for example, by what we call project ID, which at ContentSquare is customers. And we can see that a few projects really concentrate most outliers, and that allows us to go back to the original queries. So this is a bit of a contrived example, but the principle stays the same. You want to first look at the global picture and then narrow down on your outliers to then investigate more precisely. And sometimes what happens is that you detect a gap between the old system and the new system, but the new system actually works, and you find out that the bug is in the old system. And this happens quite a few times, and this is not a comfortable situation. So what do you do in this circumstance? So the The best approach is, of course, to fix the old system before you get to migrate. If you can do this, that's great. But it's a tough sell because you're going to work on an old system that's going to be deprecated. You have to do a fix on a system that you don't really know anymore. You have to test it, validate it, etc. So it's safe, it's good, but it's quite wasteful as well. The other approach, which is very tempting, is just to leapfrog this step and go directly to the new system. Leave the past behind, migrate, correct everything at the same time. Every time we chose to do that, we had to backpedal because essentially it's very hard to communicate the gaps between the old system and the new system when you switch overnight, and really hard to justify to your internal stakeholder or to the clients that basically the number changed overnight because we fixed something, as opposed to just because we messed up something when we were doing our migration. So it's very politically it's very hard to express. So instead, what I recommend is really the sad but realistic approach of first focusing on the migration, leave the bug where they are, and fix them later. So when you do a migration, you migrate first and fix and add new features really later in the second part. So with this process of looking at the result of this process of looking at the focused comparator results, fixing the issue and so on, this is a very iterative process. If you want to look at the result of your comparators, communicate those results to the company at large as soon and as often as possible, and then fix these issues. Once you fix these issues, you want to ensure that it fixed everything. You also want to make sure that you didn't break anything else. So you want to rerun your comparators, look at the new results, recommunicate this result, etc., until you are satisfied with the results, and you estimate that the gaps are small enough, at which point you can do a final round of validation using the production request comparator. You can communicate the final results to the stakeholder, who can give you a go-ahead for production. At this point, all you have to do is celebrate, or not, if the results are not good enough, and you are back to a few more weeks of iteration, of course. So that is basically the few takeaways that we could give you as part of the lesson learned by ContentSquare during those 2 successive migrations. So one, of course, invest early in tooling and automation, otherwise you will pay for it later and dearly. Migrate first, focus on migration, all the bugs that you found during the migration, leave them for later. Communicate the results of your data gaps very early, very often, to set expectations, and iterate, measure, fix, and at the end of it, of course, celebrate. And that's what I had for you. Thanks, everyone. And if you have some questions, I'll take them.